The standard structural engineering workflow operates through continuous friction. It is highly segmented, forcing engineers to push data sequentially through a disjointed pipeline. Moving a project from preliminary sizing to final SANS compliance requires massive amounts of manual data translation across isolated CAD software and disconnected spreadsheets, creating multiple points of failure. The Structural Engineering Productivity Suite by Farrow-Fons Digital directly targets and resolves this data fragmentation. This suite wraps the entire structural lifecycle in a unified, generative building information modeling and multimodal AI ecosystem. The system's foundational objective is to eliminate these traditional bottlenecks and maximize firm profitability through rigorous automation. We are going to trace this automated data pipeline from the initial architectural import through geometric optimization and commercial costing, all the way to final quality assurance. The underlying architecture relies on a hybrid system. It deploys targeted algorithms, specifically computer vision, natural language processing, and Python-based finite element analysis, exactly where lifecycle bottlenecks occur. Unlike abstract AI models, these targeted systems output directly into verifiable engineering standards, generating native IFC models and fully marked up PDFs. Achieving zero-error, highly profitable engineering requires shifting away from manual data transfer and adopting algorithmic data inheritance. The pipeline begins at the tender phase, a critical window where speed and accuracy determine whether a firm actually wins a bid. App 3, the rapid prelim design tool, targets this phase. It requires only 3 inputs: an architectural IFC model, geotech data, and the anticipated design loads. Using a Python and FastAPI backend, the system instantly analyzes the structural geometry. It calculates precise load paths for standard concrete frame structures and automatically sizes slabs, columns, and foundations in accordance with SANS codes. This reduces preliminary design time from several days to a few minutes, allowing firms to submit accurate bids with zero upfront cost. Generative sizing provides the baseline, but maximizing profitability requires rigorous value engineering. This leads directly into App 4, the Design Optimizer. This dual-engine tool parses the structural IFC model and runs hundreds of rapid iterations to balance material volume against structural requirements. For concrete structures, the algorithm calculates specific trade-offs, optimizing the depth of the slab against the weight of the required rebar. When analyzing steel, it systematically tests and selects the absolute lightest standard sections that still pass SANS codes. These continuous computational iterations ensure the highest possible material efficiency without compromising structural integrity. Automating this level of value engineering allows engineering firms to offer clients significant material savings upfront, securing a clear competitive advantage. Generative structural design turns the tender phase from a speculative expense into a precision-engineered, cost-saving asset. The next major workflow bottleneck is measurement. Quantity surveyors often need up to 2 weeks to manually extract volumes and tonnages from 2D drawings to build tender documents. This suite bypasses this delay entirely by leveraging the live volumetric data already sitting inside the newly optimized IFC model. This data flows directly into App 5, the Tender and BOQ generator, which automatically extracts the raw concrete volume, the total steel tonnage, and the formwork area. At this stage, a natural language processing engine takes over the pipeline. The NLP engine translates these raw mathematical metrics into highly specific, standard SANS 1200 formatted bills of quantities descriptions. Quantity surveyors immediately receive a 95% accurate, fully formatted BOQ, eliminating the manual measurement phase completely. The second branch of this data pipeline feeds directly into App 7, the cost calculator. This application continuously pulls the live quantities generated during the rapid prelim design, multiplying them by a cloud-hosted database of current construction material rates. The result is a real-time feedback loop. The commercial dashboard updates instantly with every single design change the engineer makes to the model. This combination of NLP data extraction and live rate polling allows engineers to quantify the financial impact of their decisions in real time, removing the need for a separate weeks-long redesign phase. Even with optimized 3D models and automated commercial data, The highest liability risk for any firm remains at the final 2D detailing and fabrication stage. App 1, the rebar review tool, is built specifically to mitigate this risk. It cross-checks traditional 2D PDF bending schedules against rebar layout drawings. It uses a multimodal AI approach. First, advanced OCR extracts tabular data from the PDF schedule. Next, a YOLO V8 computer vision model aggressively scans the 2D layout drawing. It detects specific rebar callouts, drawing bounding boxes to cross-reference sizes against the extracted data. This dual check system instantly flags any discrepancies, drastically reducing human error and enforcing strict accuracy before fabrication begins. This visual analysis extends to App 6, the drawing reviewer, which operates as an automated QA and QC engine for final PDF and DWG reviews. Its NLP component reads and cross-references general notes against sans codes to catch outdated text, while the computer vision algorithms visually redline standard detailing errors, such as incorrect lap splice locations. Parallel to the 2D checks, App 2 runs a BIM-integrated Python finite element analysis engine. It audits the proposed 3D IFC rebar detailing against SANS 10100 codes to prevent dangerous under-reinforcement or costly over-reinforcement. By layering computer vision, OCR, and NLP over traditional 2D formats, the suite standardizes the QA/QC process, flagging the detailing errors that typically lead to site delays. When we zoom out to look at the fully assembled suite, we see a complete algorithmic engineering pipeline in operation. Specific models handle specific tasks: Fast API for generative geometry, NLP for standardized SANS documentation, and YOLO V8 for precision visual quality control. The traditional timeline forces engineers to design, check, cost, and then redesign in a slow, sequential loop. This ecosystem replaces that with parallel processing. Generative design, rigorous value engineering, commercial costing, and senior-level compliance checks all happen concurrently. Engineering firms can now bid on a higher volume of projects with exact cost certainty and lower detailing risk. The suite uses AI to apply rigid, code-compliant automation at every major bottleneck of the lifecycle. By automating the data flow from preliminary design to final QA, the Ferrum Fonds Digital Productivity Suite provides engineering firms with the speed and accuracy required for modern project delivery.